We're going to do some brief review of Algebra 1 before we dive into our first chapter of Algebra 2 trig. So some graphing in slope-intercept form, point slope form, and standard form, clearing fractions and squaring things. I'll try and be concise and brief. I'm going to graph this, which is in slope-intercept form, which we often think of as y equals mx plus b, where m is your slope, which in this case that's negative 5 over 2, and b is your y-intercept, which in this case is a positive 12. Now, the grid that I have over here doesn't have any axes drawn on it. There's no x or y axis, and I'm going to do that a lot because I think it's important that we learn to draw our own and to think through where it is that we want them. You don't always want to put it right in the middle. If I were to just draw an x-axis here and draw a y-axis here, I can't easily get up to a y value of 12 unless I count by 2's. And I could count by 2's, but what I could also do is just have a little bit of foresight and move this thing way down here to make sure I can count up as high as at least 12. And I'll take this line and extend it a little bit. And now this is my x-axis, and this is my y-axis. And I'll go 1, 2, 3, 4, 5, and negative 1, negative 2, negative 3, negative 4, negative 5. And hopefully I can get as high as 12. Yeah. Now, when I'm graphing, this is in slope-intercept form, as I said before. I want to start with the y-intercept. The y-intercept was 12, so I'm going to put a point at 0, 12. That is the y-intercept. If you're in slope-intercept form, it always comes from this number out here. Now, the slope is negative 5 over 2. This means I'm going to go down 5 and right 2. I can do that from any point that I want, any point that I have on the graph. Right now, the only point that I have is the point 0, 12. So from this point, I count down 5, right 2, and that's one point on my graph. Then I'll go down 5 again, right 2 again. There's another point on my graph. Now, once you have 2 points, you can connect them. 2 points make a line. But the further out you can space those points, the better. Here is the graph. There's a couple things I want to make really, really clear. One of them is, if ever the slope is negative, I always think of that as being down, never left. So this is going to be down 5, right 2. The top number is telling you how far up or down to go. The bottom number tells you how far to the right to go. Always go to the right whenever you can, meaning if you have space to the right, go to the right. So this is down 5, right 2. Another thing I want to stress, this is the graph. The line that I plotted is the graph. All these points out here, this is part of the grid, or we call it the coordinate plane. So graph paper is not called graph paper because it's paper with pages with a bunch of graphs on it. It's called graph paper because it's the paper on which we graph. So the grid in the coordinate plane is not the graph itself. The graph is the actual line that I drew going back and forth. And the last thing I want to point out is I could pick any point on this line at all. Like this looks like it's the point 0.5, 11. It's probably not exactly that, but it looks like that. Every single point, any point on this line, whether it be whole numbers or not, every single point on this line, I could plug in for x and y and get a true statement, to get something that works. For example, this is definitely the point 4, 2. Well, the x value is 4, the y value is 2. If I plug a 4 in for x and a 2 for y into this equation, I'll get a true statement. So y was 2, x was 4, and then I do some multiplication. This is really a fraction 4 over 1, so I'm doing negative 5 times 4 to get negative 20 over 2 plus 12, and I want that to equal 2. Well, negative 20 over 2 is actually negative 10. So we get 2 equals 2, which works. Every single point on this graph would work in the equation. That's what a graph is. A graph is a picture, a visual representation of all the solutions to an equation. This is in point slope form. Now, you might not have seen point slope form before. I hope you have. It's wonderful. Point slope form has this formula, y minus y1 equals m times x minus x1. And just like before, m stands for your slope, which in this case is 6. Very, very steep. But it also, instead of giving you a y-intercept, it gives you a point. So the point is always coming in the form of x1, y1. x1, y1, that's a big comma in between them. And so the point x1, y1 in this case is going to be -2, +4. The thing that throws people off about point-slope form is the fact that you have to switch the signs of the numbers as the points. So that was a +2, it switches to a -2. This is a -4, it switches to a +4. And that happens because there's these negatives in the formula, y minus y1 equals m times x minus x1. The negatives, minus y1 minus x1, cause you to flip the points around. So now I'm going to graph this point. Again, I want to think through where I want to put my axes. And one thing that I can do, and this is always a pretty good idea, is, well actually, I'll do that later. I am going to do my good idea later. And for now, I'm just going to graph this. And I think if I put this right in the middle, more or less in the middle, I should be okay. When you're graphing point-slope form, you start at the point that you're given. In this case, it's the point -2, -4. No, -2, +4, excuse me. Here. Here's the point, -2, +4. Then my slope is 6. Well, like I said, with slopes, you should always go to the right. So if your slope is 6, that's really 6 over 1. You're going to go up 6, right 1. But on my grid, I didn't give myself enough room to go up 6. I only have up 4. So instead of going up 6, right 1, I can go down 6, left 1. And down 6, which I actually don't have room to go more than one step either direction. What I could do is just take everything and slide it up or down just a little bit. Like I could even just move all my dots like this. Just move my grid around. And this will give me enough space, well, hopefully, I can grab it all, not drag it all down. This will give me enough space to go up 6 more and right 1 more. So it's a very, very steep slope, very positive slope, and that's point-slope form. If you have not seen this before, it is really worth taking some time to practice it, play with it, maybe find some other videos or practice on it, because it is very, very helpful and very, very useful, because you can graph from points that don't have clean y-intercepts. Not every graph has a clean y-intercept, but every graph will have a clean point somewhere. Okay, I'm going to keep going. This is standard form. Standard form is ax plus by equals c. It's a color we haven't used yet, and I'll stay here. It doesn't tell you anything right away, but you can find things really easily. The x-intercept is always c divided by a, which in this case is 12 divided by 4, because a is 4, b is -3, not +3, but -3, and c is 12. So c divided by a gets you the x-intercept, which is 3. The y-intercept is c divided by b, which is going to be 12 divided by -3, which is -4. And the slope, a lot of people don't know this one, but the slope can actually be found as doing -a over b, which is going to be -4 over -3. The negatives cancel, so the slope is just 4/3. X-intercept 3, y-intercept -4. This is another graph I can put right in the middle. I'm just thinking through where my points are and how much space I have to give on my graph. And that might be a little bit to one side, but I'm not too worried about it. So x-intercept at 3, y-intercept at -4. Slope should be up 4, right 3, which it is. And I graph this. Always use a straight edge, and because I'm on a computer, I've got a really nice, handy straight edge here. Let's put some labels on this. Here's my x-axis. Here's my y-axis. 1, 2, 3, 4, 5. Beautiful. Okay, moving on from lines. Fraction stuff. I just want to briefly cover how fractions work, because I know you forget or you get confused, but most of I know that you hate them. 5/4 plus 5/3 does not equal 10/7. Not at all, not at all, not at all. You have to have a common denominator. Denominator means the bottom part, not the top part. So I'm going to multiply this by 4 over 4, and this by 3 over 3. Now it's important to understand what I'm multiplying by here is 1. 4 divided by 4 equals 1. And you can multiply by 1 at any time you want in any problem, because multiplying by 1 doesn't change anything. It's one of the tools we can use in algebra at any time. Multiply by 1 doesn't change anything. And I picked the 4 here and the 3 here to make 12s on the bottom. That gets me a common denominator. Denominator means the thing on the bottom. You only need a common denominator if you're adding or subtracting. You don't need it for multiplying or dividing. Let's pull this out of the way. So now I'm going to have 15 over 12 plus 20 over 12. I just multiplied everything on top and bottom. Now that the denominators are the same, this adds up to 35 over 12. If this could reduce at all, I would reduce it, but 35 can't divide by 3 or by 4, and 12 is just 3 and 4, 2 and 6. So there's my fraction, 35 twelfths. Now 35 twelfths is a fine answer. If you think everything needs to be made into a mixed number, that is incorrect, but you can do it. It's the same as 2 and 11 twelfths. But improper fractions, which is this one, are often easier to work with than mixed numbers. Mixed numbers are usually more helpful for communicating things. Like if you asked me how far I ran today, I would lie and say I ran 2 and 11 twelfths miles. I wouldn't say 35 twelfths miles. Nobody speaks this way, but it's easier to work with these. But if the honest answer of how far I ran today would be 0, because I don't do that. So here, the next one to the right, the question can become, well, what is the lowest common denominator? That red is too dark. This is a fraction. Every number is a fraction. Okay, so if you see a number that doesn't look like a fraction, it is, put it over 1. So we have 2 over a plus 3 over 1, and I want a common denominator. That common denominator is actually a. I'm going to multiply this by a over a, and I get 2 over a plus 3a over a, and now I have 2 plus 3a over a. 2 and 3a are not like terms, so I can't add them. That's not 5a or 6a or something like that. It's just 2 plus 3a. And you might be tempted to say, okay, well now I can cancel these a's. You cannot. You cannot cancel part of something from something on top with something on the bottom. 2 plus 3a over a is not the same as 2 plus 3. I'll give you a simpler example. Suppose we had something that was like 3 plus 4 over 4. And you're thinking, okay, I can just cancel those 4's and get 3 plus 1 over 1. Well, now what you're saying is that 3 plus 4 over 4 is the same as 4, because this is a 4. And it's not. So you can't just cancel these parts, just those parts of a's. If there's addition on top or bottom, you can't cancel things that are there. We'll talk more about that in a much later chapter. 2 more quick little things. This is division of fractions. Think of this like it's 2/3 divided by 4/5. I know you see a fraction and a fraction with fractions dividing fractions, and there's incepted fractions in these fractions, and there's so many fractions, and I've said the word fraction so many times that your stress levels are rising. But calm down. It's just a fraction dividing a fraction. And to divide fractions, you take the second fraction and you flip it over and multiply. And one day I'll talk about why that is, but today's not that day. With multiplication, just go across the top and the bottom. 2 times 5 is 10, 3 times 4 is 12. You don't need common denominators when you're multiplying. You just multiply. Now this can reduce. 10 and 12 can both divide by 2, so it's 5/6. You have to reduce every fraction you ever do. Always reduce. Now reducing is not the same as converting. Here I converted. I went from a mixed number to an improper fraction, or other way around. That's converting. You don't have to do that. You always have to reduce. Put a fraction in its smallest forms. Another option is you could have gone back to this step here and seen that 2 and 4 can both divide by 2. And then you get 1 times 5 is 5, and 3 times 2 is 6, and you get 5/6 that way. Another very good option. Now, all this fraction work is meant to make problems like this easier. This problem looks like a nightmare because you hate fractions so much, and I understand that, but we're going to do them enough that you won't be so scared of them, because really they're not all that scary. I'm going to get a common denominator, which means I can't use white. I'm going to go to, let's pick this yellow. I like this yellow. Right now, everything has a denominator, 2, 1, 5, and 6. I want the lowest common denominator of all of those numbers, of the numbers 2, 1, 5, and 6. And if you ever aren't sure, you can just multiply all the numbers and see what you get. 2 times 1 times 5 times 6 is actually 60, so I could do 60. But it turns out, since 2 goes into 6, I I can do it faster. All these numbers go into 30. 2, 1, 5, and 6 can all go into 30. So the lowest common denominator is 30. So I'm going to make all of these numbers have a denominator of 30. Multiply this by 15 over 15. Multiply this by 30 over 30. You can probably barely read that. Multiply this by 6 over 6. And multiply this by 5 over 5. I multiplied each individual piece by the number 1, but those 1s are all kind of sneaky to get me what I wanted. Now I have 15x over 30 plus 90 over 30 equals 24 over 30 minus 35x over 30. Everything now has a common denominator, which means I can drop the denominators. I can literally just get rid of them. What I'm going to do to make that happen is multiply both sides by 30. And when you multiply by 30, you have to distribute, and these 30s all cancel. And hallelujah, we've made a new problem with just whole numbers with a slightly different yellow color. Now I can just solve this problem like it's basic algebra. So I'm going to add a 35x to both sides and subtract a 90 from both sides. And that gets me 50x equals negative 66. So x equals negative 66 divided by 50. I divided both sides by 50. I should probably show that step. I divided both sides by 50. And I can write that as, I can reduce that to negative 33 over 25. And if you want to make that negative 1 and 8/25, that's fine, but you really don't have to. There's our fraction review. Finally, probably the most common mistakes made in algebra comes from squaring things. To square something means you multiply it by itself. So a plus b squared is really a plus b times a plus b. This is not, oh my gosh, it is not a squared plus b squared. Not at all. Don't ever do that. But you're going to, because it's the most common mistake in algebra, in my opinion, at least top two. I'll show that one on the same slide. This needs to be FOILed. So you end up doing a squared plus ab plus ab plus b squared. A times a is a squared. A times b is ab. B times a is ba, which we'll call ab. And b times b is b squared. These two things can combine. So it ends up being a squared plus 2ab plus b squared. In the same way, a minus b squared is not a squared minus b squared, and it's not a squared plus b squared. This becomes a squared minus 2ab plus b squared. Not a plus, but a minus. So for example, I'll do one that's kind of a pain here, but not that bad, so you can do things like this once you get the feel for it. 2x minus 3y squared is 2x minus 3y times 2x minus 3y. To square something means you multiply it by itself. Actually write that out. Now, 2x times x, 4x squared. 2x times negative 3y is negative 6xy. That's all we can do. Just write the xy next to each other. You need common denominators to add and subtract, but not to multiply. And I'm sorry, I said common denominators. You need like terms. So 2x and 3y are not like terms, but you can still multiply them. You can multiply anything. You can't add 2x and 3y because they're not like terms, but you can multiply them. So next, negative 3y times 2x is negative 6xy, and negative 3y times negative 3y is positive 9y squared. I can combine these two things because they're like terms, so I get 4x squared. Then with these I just combine the coefficients, so negative 6y minus 6y is negative 12xy plus 9y squared. Boom. That is how you square things. That's how you square binomials, technically. A binomial is a two-termed expression. It's squaring binomials. Okay, take a second and guess at what these answers are. I'm going to knock them out real quick, but maybe pause and guess and see if you know what these work out to. This is negative 9. This is 9. This is negative 27. This is negative 27. And if there's one that you got wrong, it's probably one of these two. The order of operations matters and the parentheses matters. With this, you're doing the 3 squared first, because by order of operations, you do exponents before you multiply. and the 2 is an exponent, whereas this negative is a multiply. It's like you have negative 1 times 3 squared. That's really what that's saying, negative 1 times 3 squared. So first you do 3 squared to get 9, then it becomes negative. That one's very often missed. Whereas this one means negative 3 times negative 3. The negative 3 is in parentheses, so negative 3 times negative 3 is positive 9. So this is 3 to the third first, which is 27. Then this makes it negative. This is negative 3 to the third, which is actually just negative 27. Because it's negative 3 times negative 3 times negative 3, which goes negative, positive, negative. If you have an even power, it can come out positive. If you have an odd power, it always comes out negative. Okay, I know that was fast, but I hope it was review and just sort of things to get clear and get your mind straight. I hope it was helpful. Thanks for watching and have a nice day. Hey, thanks for watching. I hope that was helpful. If you have any questions, leave them in the comments down below. There can be questions about the video you saw here or anything else in math I'm happy to help with. Subscribe if you'd like to watch more videos or see other updates as they come. I'm going to try to run through all of Algebra 2 Trig and then eventually hit more classes like Algebra 1 and Geometry and Pre-Calc and everything else. If you have questions about stuff covered that's not in this video, still let me know. I'm happy to help. And finally, if you're not one of my students taking the class, but you found the video and are watching it, or maybe you're a teacher and are watching it, you can buy the curriculum and buy the worksheets to go through it. That's found at the website listed down below also. So again, thanks for watching. Have a wonderful day.